But I want to know a little bit more about the weaponry used in Star Wars. It's like this red flashing beam of light that's coming out of the gun or the ship. If we try to look at it from a scientific point of view, what do you think we're looking at?
So these weapons, the blasters, they cannot be lasers. The speed of light is instantaneous in everyday life. But what we see in the movies, we see these blasters moving at a finite speed. So the most likely thing, these can be plasma blobs. A plasma is sometimes called a fourth state of matter. Picture a plasma like a gas, but a special type of gas. It behaves very differently from a normal gas. If you pump energy into this gas and you ionize the atoms, meaning the electrons have so much energy, they're not bound anymore to the atomic nuclei. That's a plasma. Now, a plasma, it will dissipate. It will not just stay there as a blob. So somehow you need to confine it. You need to generate an electrical current in the plasma. This current will produce a magnetic field, and this magnetic field confines the plasma. This is how people try to confine the million-degree temperature plasma. Then you could shoot that thing. And apparently, the US Air Force is working along those lines since the 1970s. This is the Shiva Star program, which is classified, but apparently they have produced plasma-based weapons. So this is not entirely science fiction.
So entertain me a little bit. Let's talk about some of the science behind Star Wars lore, let's say. We spoke a little bit about speed traveling, but I want to know a little bit more about the weaponry used in Star Wars, because a lot of the Space Wars themed movies show what you would call, like, I don't know, laser weaponry. It's like this red flashing beam of light that's coming out of the gun or the ship. If we try to look at it from a scientific point of view, what do you think we're looking at?
So these weapons, the blasters, for example, they cannot be lasers. Lasers, this is just coherent light that's very energetic. If you turn on a flashlight and you're outside, you cannot even see how these things move. It's on these distances. The speed of light is instantaneous in everyday life. But what we see in the movies, we see these blasters moving at a finite speed. So they cannot be lasers. Also, if you have a laser beam moving in vacuum, nothing will scatter it so that you can see it. You would never be able to see it. You only see the impact. So in other words, again, what you're seeing in the movies cannot be lasers.
Yeah.
So the most likely thing, what they can be, is these can be plasma blobs. A plasma is sometimes called a fourth state of matter. So the other states of matter are solids, liquids, and gases. And picture a plasma like a gas, but a special type of gas. It behaves very differently from a normal gas. And if you pump enough energy into a gas, atoms consist of atomic nuclei. We talked about those. They fuse in stars and generate energy, but also there are the electrons. And a neutral atom will have as many electrons as there are protons in the nuclei. If you pump energy into this gas and you ionize the atoms, meaning the electrons have so much energy, they're not bound anymore to the atomic nuclei. That's a plasma. So essentially, it's a gas where you have free electrons and ions left behind instead of neutral atoms.
And it has a lot of energy in it.
You need to pump energy into it to ionize the matter. Now, the temperature, how hot it is, that depends on the density. A neon light, for example, is a plasma, but it's not very hot. You can touch the bulb because the density of the gas inside is very, very low. But these blasters that you see in the movies, those are most likely plasma blobs. Now, a plasma has so much energy, if you want to make it into a weapon, it got to be really hot, that it will dissipate. It will not just stay there as a blob, it will dissipate. So somehow you need to confine it. This again now becomes a technological issue, not a fundamental physics issue. You need to generate an electrical current in the plasma. This current will produce a magnetic field, and this magnetic field confines the plasma. This is how people try to confine the million degree temperature plasma by magnetic fields. So if you now think much more smaller, you create a plasma blob, a current, it generates a magnetic field, and that confines the plasma. Then you could shoot that thing. And apparently, the US Air Force is working along those lines since the 1970s. This is the Shiva Star program, which is classified, but apparently they have produced plasma-based weapons. So this is not entirely science fiction.
So what would happen if, let's say, a plasma ray that we're talking about hits a wall in the real world? Like, would it go through it? Would it melt it? Would it ignite it?
So it is so hot, this plasma, if you want to build it as a weapon, that it will just burn through it. It will melt it.
And what's the physics on that ray? Is it traveling super fast because of the charge? What's making it travel?
No, this is an independent issue. You also need to give it some propulsion, some speed.
Okay.
And there are different ways of doing this, but that has nothing to do with the concept of a plasma.
Right,
so you need some technology, maybe a rail gun to make it really travel very fast as you can. And there may be technologies that they could make this plasma move with a fraction of the speed of light, which would be incredibly fast. But such plasma blobs would be able to destroy spaceships.
I'm assuming that the same technology that we're talking about for a blaster is what we could potentially use for creating a real life lightsaber.
Correct. Yes, because they cannot be light. They're not lasers, because lasers work completely differently. You turn them on and then the light ray goes very fast. So they must be based on plasma technology. And you can again think of a long tube of a plasma blob that, again, you would need to produce an electrical current that generates a magnetic field to confine this so that you produce this lightsaber. But there are major issues. If you are in a lightsaber fight, if you could manage to produce these plasma tubes, they would just move through each other. So somehow, that's not what we see in the movies. So somehow you need to maybe have a solid core inside that tube. But of course, if the plasma is very hot, it will melt every solid. So you need to find some material that doesn't melt easily, that doesn't exist right now. And of course, if the plasma is so hot, I mean, you want to wield a sword. You gotta make sure that the heat does not melt the arm of the person who's wielding the lightsaber. But you see, again, these are technological problems, not problems based on our fundamental understanding of physics.
Okay, so question. Is there some way that like there could be some sort of magnetic field that when these two plasma rays collapse, like they're actually bouncing on each other instead of going through? That's the only thing that I can think of.
Well, there could be maybe a very smart arrangement of electric and magnetic fields that perhaps could do that. But then if you look at a lightsaber, it's a small thing when you see it in the movies.
You mean like the actual technology, the handle?
Yeah, all the technology that produces any of these things we're talking about, the current in the plasma, and so that needs to be put all into a very small space. And right now, these things will take a vast amount of room to ensure this technology.
What about if you implement some sort of theory of quantum mechanics? Wouldn't quantum mechanics say that there's a small percentage that the actual plasma rays would actually bounce each other?
So in terms of quantum mechanics, yeah, it's a probability argument, which if you're in a fight with lightsabers, maybe you don't want to throw dice and take your chances. So if the probability of what you just mentioned, even if it's possible, if it's very small, it's like 1%, you don't want to go into a fight like that and place your odds on that.
No. So one of the other thing that you were mentioning is the shape of it, right? The uniformity of the shape is something that is technologically an obstacle.
This will depend on the magnetic field that is confining the plasma. So that's shaping then this weapon.
And like, how much energy do you think we need to actually create a plasma lightsaber? Would you say like?
Oh, that I don't know. That I do not know. But again, this is a question of technology. If you think about people who welders, for example, they're very familiar with plasma cutters. And this is a device you can buy for $400. It's a box this big, and you just put it into a normal outlet, and then you can cut through steel that's a few millimeters thick by using this plasma cutter. And
What's it? It's burning. It's burning gas, though, right?
no, it creates a plasma. That's why it's called plasma cutter. And then the temperatures are so high that it burns through steel. So my wife, for example, is an artist. She uses a plasma cutter all the time to cut metal for her artwork.
But what source of energy is it using? What is it?
Oh, she just plugs it into an outlet, a
What?
normal 110 volt outlet.
What? And you just press the button and it goes like.
Exactly. Exactly. Yes.
I see. So we just need to keep working on that.
Yeah, so all I'm saying is, I know that many people think lightsabers, oh yeah, this is not possible, or maybe that technology is, 100 years away. I think we're much, much closer to that than what many people think.
Well, that's awesome.